I'll be talking about a few things today which are very different to what you have been witnessing outside in the exposition. It is related to how things are changing as far as technology is concerned and how technology is actually driving the changes in the chemical industry and the industries in general as well. Now, if you look at it from the times that we have been producing since 1800th century, we have come a long way as far as manufacturing technology itself is concerned. But one thing that is now driving the change is the mixture of core technology, or engineering as we call it, mixed with IT, a data-driven revolution which is trying to change the way we've been functioning. I'll be taking you through why certain things have evolved in a certain fashion, and also we'll be taking a look at some of the marquee case studies from Europe, wherein chemical manufacturers have actually embarked on a journey which is very futuristic, but holds a very big promise of how you can actually look at producing more with less. Here's a quote from Friedrich Nietzsche. Friedrich Nietzsche was a German philosopher, and when he says that the snake which cannot cast its skin has to die, he's trying to say that if you are coming with preconceived notions about things and your mind is not open to reception and change, then your mind ceases to be a mind. In a sense, what he's trying to say is that we all need to change with the changing times. And change is also a chance to do something new, a chance to embark on new endeavors which can bring in more fruits than what you have been used to. We all change. Things have changed. If you look at the genesis of music players, we started with gramophones, we came down to spool players, MP3 players, and so on and so forth. And right now we talk about everything which is digitized and put in cloud, and we access it through our phones. Places change. So what you're seeing here are pictures of Marine Drive from back in 60s, I believe, and what it is now. And people change too. So if you see that always has been a growth journey associated, be it things, be it places, be it people. As far as industry is concerned, industry has changed and come a long way as well. If we talk about the first industrial revolution, it was powered by steam engines and the invention of steam itself. It led to a big mechanization, the industrial revolution for mills and for fabric productions in UK. Then electrification came in the late 1800s, and things changed again. In 1969, we changed the industry's outlook again by having a lot of semiconductor-based and a lot of electronics-based interventions. That meant that the PLCs that we see today, the DCS systems, and all those things actually came from the genesis that took place in 1969. Now we are talking about a fourth revolution, which is led by IT. And here we are talking about how do we use the data that's coming from our machines, how do we use the data that's coming from our processes, and how do we mix them up together to make sense of how to operate our operations in a much more streamlined and much more agile fashion. My name is Rajat Sabharwal. I lead the technology function at Solulever B.V. We are based in Amsterdam in Netherlands. It's a company focused on digital manufacturing and bringing the change of digital to the processes and to the assets that you run on your shop floor. I'm also a co-founder here, and today I'll be talking about limiting operational losses with digital manufacturing. So what is digital manufacturing and what changes is it actually driving? Well, at the center of it all, it's efficiency. And when we say efficiency, it has multifarious meanings. Efficiency is not only limited to your assets, it's not only limited to your processes, but it's also limited to every resource that contributes towards the creation of what you're creating on your shop floors. And efficiency is bottom line. And for any kind of bottom line improvement to happen, you need to have, first of all, a resolve, but also the toolkits to make things more efficient and more in line with the expectations of the board. Now, there are other things that digital manufacturing is driving. One of those things is sustainability. However, for the topic of today, we'll be mostly talking about how chemical manufacturers in the Western world are trying to make use of these technologies from a bottom line improvement perspective. Now, everything has to be backed up by a business case, And a business case is basically the Bible, which drives these endeavors for a particular organization. I'll be showing you some numbers as to how these initiatives are stacking up across multiple regions, be it Europe, be it US, be it some of the advanced countries in Asia Pacific. The survey that you're seeing here, I don't know if it is visible to you at the back, but the survey that you're seeing over here is conducted across 1,000 executives from companies which are $1 billion plus revenue. And here you see that industrial manufacturing, chemical processing is part of industrial manufacturing, is actually leading as far as smart factory initiatives are concerned. So 67% of $1 billion plus companies which were surveyed, and this is an extensive survey that carried out for close to 1.5 years, they have some kind of a smart manufacturing or a smart factory initiative running. And they are spending in big time. Now, when I say spending in big time, there are greenfield, there are brownfield, and both green and mix of both greenfield and brownfield initiatives which are running. And here again, if you see, there is a great amount of money in the excess of 250 million to 500 million, which has been earmarked for such initiatives over the next 5 years. Now, this is big chunk. Why are companies actually looking to spend so much of money and not really set up new operations itself, but also streamlining their existing brownfields? We'll have a look at that. The reason is that smart factory initiatives are turbocharging the way you're used to running and the way you actually imagine your operational savings. Now, we all know about the Six Sigma revolution and what it meant for manufacturing. But if you take a brief history of how things have evolved since 1990, 1990 is taken as a baseline because that's when most of the companies had a Six Sigma initiative running on their shop floors. What you see here is that with the use of digital technologies, since 1990, the comparison to today with digital technologies, your on-time delivery, if you're using some kind of a digital platform for tracking your on-time deliveries, your on-time deliveries have gone up by 13x. So it used to be just 0.42%. So the benefit through Six Sigma was just 0.42%. But the benefit with digital technologies and the use of these technologies correctly leads to up to 5.5% improvement in your on-time deliveries. Similarly, quality and scrap, you see a 12x increase. In CapEx and inventory usage, you see again a 12x increase. Material logistics and transportation costs, 11x increase. Labor cost, quite interestingly, with the use of these technologies, you can actually see the cycle times, the process adherences, how much time is actually being used by a particular operator to produce the units that you're used to measuring. The labor costs have seen a 9x impact if you're using digital technologies. Basically, what it's trying to tell you is that if you're trying to market with the dollar value, all these initiatives give you a return which is quantifiable and which is there and real. So the overall productivity that we look at, the impact of digital technologies has been close to 5%. Now, this is big number if you're talking about an expense sheet of manufacturing of $1 billion plus organization. What are most of the companies looking to spend on? One of the things that comes to mind, or rather it's on the top of the agenda for most of our key customers, is OEE improvement, the overall equipment effectiveness. Why is it important? Because assets are money on books. It's capital expenditure on books. And you have to maximize the utilization of your assets. Things like digital maintenance systems, things like our root cause problem solving systems which are helping you come down to a root cause why a particular failure is happening over and over again. Predictive maintenance, so when can you actually say is the right time to do the maintenance? Can I predict when my asset is going to fail? Yeah, all these kind of applications which were actually unheard of, say about 5 years back, are really now gaining steam. Things like digital twin, which is a virtual twin of the assets that you're running on your shop floor, is again a technology which is picking up and giving you real-time visualizations as to when your asset failures are going to happen. Now, this is coming from a real case which we implemented with one of the chemical manufacturers in Europe. And the good number to see here is 15% increase in the overall utilization of the assets. So if you had 100% availability of an asset to begin with, they were only utilizing 65%. The reasons were related to maintenance, changeovers and cleaning times, micro stoppages, scraps, and so on and so forth. So even if the asset was available to you for 100% time, you could only derive value from it for 65% time. Now, with the use of these kind of tools, you are able to drive 15%, and that's a big number again in terms of the dollar value saved. Digital quality control is again one thing which is driving a lot of change, especially in the European sector, and this is again coming from the case study done with a chemical manufacturer in Europe. Here, if you see, there are two basic facets that any manufacturer is now looking at in the Western world. One is how do I get rid of paperwork? How do I ensure that my manufacturing goes paperless? And that's where document automation is coming and playing a big role. Things like robotic process automations. So when your quality control guy is doing a certificate of authorization on the raw materials that he's receiving, or when he's doing a certificate of authorization when your final goods are ready to be dispatched, all these kind of paperworks are actually being now looked at from an automation angle. So you don't have to really do checklists after checklists to make sure that the audit trail is in place. Things like optical character recognition are again playing a big role here. The other thing, so that's one. How do I go paperless? The other thing that is really gaining steam is inline quality control. That I don't have to take samples from my produce and go and test it in a lab, because it has a cycle time associated with it. So can I have instruments, digital instruments, which can be part of my line, and as the production is happening, I'm able to do quality control before even the final product is rolled out. So this is the second area where a lot of effort is being spent. So things like common data platforms, IoT platforms, and a lot of instruments attached to the IoT platforms to drive quality control in an inline fashion is really, really gaining steam. And here, the thing to note is that it is not just about saving your quality control personnel's effort and bringing down the cost of doing QC. It is also about being right first time. It's also about making sure that you have less scrap happening on your shop floors. Now, the case study that we did, however, was only focused on tracking down the QC effort. And here again, a 5 to 7%, depending upon which plant we are talking about, a 5 to 7% reduction in QC effort was seen because of these interventions that were deployed. The last part with this particular case study is about digital standard operating procedures and the process adherence. Now this, if you look at it, it's an interesting journey. We started with the OE, which is about assets. We talked about QC, which is more about effort and material, that is scrap. The last part is got to do with how your personnel are actually performing, how your operators are performing on the shop floor. So people, processes, and people, assets, people, and processes all form a part of the bottom line improvement plans that you should put in place as far as digital or smart factory initiatives are concerned. And here, when we talk about standard operating procedure adherence, it's a very interesting thing. You see, Europe has an aging population. So what it means is that the operators which are retiring from the workforce, you don't have enough people joining in back because the young population is lesser as compared to India. So the availability of operators is a big challenge. Then these operators have been working all through their lives on the same processes. So they have experiences like 35 to 40 years of doing the same thing over and over again. Imagine if such an operator retires and you have a new one coming in. He doesn't have that knowledge. And it's a big knowledge gap that suddenly you find on the shop floor, and how to bridge that. So companies like Nourion, companies like AkzoNobel, companies like BASF, they started doing a whole lot of research and implementation of what is called real-time process adherence. What you actually do in these use cases is basically you digitize your standard operating procedures. Your recipes are already digitized in your ERPs or wherever you've stored them. But the SOP to produce them is then digitized and in real time administered on kiosks next to the machine, which is like a step-by-step guide as to how to run the process. Now, because of this, one is that you're able to instill best practices on the floor, and the other is that you're able to bring down the knowledge gap. The third thing to note over here is that if you just display something that these are the steps that you're supposed to do, that's like reading a book. But how do you measure it in real time if the guy has already done what he was asked to do? Is he actually following the steps that are being displayed on the screen? And that's where the tricky part lies. That's where a whole lot of automation needs to be built in. Now, where chemical manufacturing actually benefits from, that most of us have invested in things like distributed control systems, the DCSs. And it means basically that a basic foundation of data gathering is already in place. So how do we actually make use of all that data that our DCSs are throwing at us, and imagining use cases which can be built with those data sets is what the next step towards digitization is. And that's what happened here. So right from the picking operations, the picking of raw materials, to the pallet management, to the track and trace of materials, even down to the worksheets and the logbooks that the operators are supposed to fill in. Everything was digitized. And this again led to a saving just on the effort side on 5 to 7%. Now, if you're able to shave off these big numbers on your OPEX side, that's actually adding a lot of profitability to your books. Now, when we talk about the chemical sector and manufacturing in general also, there are two ways to look at these use cases. One is revenue-focused use cases, and the other are cost-focused use cases. So if I talk about capacity utilization and workload management, that is more on the revenue side. If I talk about the production asset maintenance, that's also seen on the revenue side, because your asset utilization goes up, which means you can produce more, which means you can have more revenue. The product quality optimization is on both revenue and cost side. The reason is that quality has both the facets. One, cost of poor quality going down basically has a big impact on my bottom line. But at the same time, quality increasing means that I can ship more. Yeah. So basically, if we start looking at where a particular use case is creating an impact, and then we chart out a business case from what are the advantages I get and how do I calculate my return on an investment period, then these digital technologies make a lot of sense to invest into. But the reality remains that less than 3, so 3 out of 10, that's 30%. That only 30% of manufacturing organizations actually implement use cases which are high potential use cases. Most of them get lost in the, I would say, glamour of digitization. They start looking at things like augmented reality, virtual reality, use cases which are more fancy than giving you bottom line improvements. And hence, it's very important to quantify and justify the efforts that one is going to align towards building up a digital repository of use cases and ensuring that we are able to drive this with some kind of a business case mentality. What companies who are succeeding, what are they looking at? One, they review their current capabilities and know their gaps. Not all the gaps can be filled from in-house. You have to have your partner ecosystems helping you out, but at the same time, you need to be realizing that there's a lot of skill set available within your house. People, there are star performers on your operation side. What kind of a career graph are you giving them? Are you giving them the capability to learn something new, something like data science, and use their operations experience in building up predictive models, building up really the, I would say the crux of intelligence which they have gathered over a period of time. They also look at investments in data analytics field, and at the same time, security is always at the top of their minds. So they also, focus on how do we alleviate any concerns related to IoT, sensors being put on the shop floor, data flowing to the cloud. Am I opening up myself for cyber attacks? So security, analytics, and the skills required to deliver are the three lenses that are applied to ensure that the programs that you stitch together are of meaningful importance. And at the same time, it's important to have a vision. Now, the company I was talking about, they had a clear-cut vision that they wanted to increase their return on sales by 15% in the year 2020. So they clearly came out with a vision that we need to be, axing down any wastages on our shop floor, and we need to be doing more with less. That vision needs to come in first from the top bracket, because until and unless there is a vision being set, then everything else goes like a headless chicken run. Now, companies which have succeeded with their digital manufacturing programs actually believe that having a vision, 85% of them believe that having a vision is much more important than anything else to begin with, and then ensuring the right executive coverage. What this means is basically it is not one man's job to run these programs. You need to have involvement from your board, you need to have involvement from your IT, you need to have involvement from your business side, from your operation side, to make it a joint working team which can deliver these programs. What we are seeing in India with some of the big manufacturers that are also out there, I can name them, UPL, Aarti Industries, they have appointed chief digital officers, people who are responsible for taking these initiatives to the floor. And it's all happening within your own ecosystem. You'll see, if you start talking to some of your friends from these companies, you'll realize how much of money is actually being spent on these use cases. And it's not a fantasy anymore, it's the reality of the competition. Because if your competition is able to produce more at a lesser cost as compared to you, it certainly says something about your own production. Again, talking about the fact that use cases need to be linked to business goals and initiatives, 43% of the companies believe this, that until and unless I have a business case, I will not implement any technology. I will not spend a single dime on it. Now, this is a whole lot of hocus pocus, so I'm gonna skip this one. The reason is because it's not probably clearly visible at the back. But I'll give you a gist of what this talks about. It talks about start with the priority portfolio and go to value engine. Priority portfolio is something that has proven value and it can be implemented in a short span of time. Yeah, and these use cases are about asset utilization, about improving your overall equipment effectiveness, but they graduate into the value engine, which takes more time to implement but gives you a whole lot of value again. Things like predictive maintenance. Another thing which is taken up big time, especially in the European context, is centralized command and control centers. Multiple plants, multiple units being monitored from a single command and control center. It has a huge benefit in terms of your supervisory cost coming down. So if you think about it, 20 units are being looked at by a single guy sitting in a CCC room and visualizing how the processes are actually running on the shop floor. If there are any stoppages, unplanned stoppages happening, if there are any kind of process leakages happening. And these centralized CCC are easy to build because you already have SCADA visualizations available. You can extend your SCADA visualizations on a CCC environment and make these use cases possible as well. Just to let you know what your competition is up to from a European perspective, important to know because of the fact that whatever starts from Europe and US actually trickles down into Asia as far as technology adoption is concerned. Now, this is a very futuristic roadmap. This is coming from a large Dutch chemical manufacturer. They're talking about dark factories. Dark factories are factories which do not need any lights. So basically, you can run your operations without any lights. Of course, you need power to run the machines, but no lights for people to see things. Why? Because there are no people. So they're talking about hyper automated factories which can basically run without people. With the help of centralized command and control centers, you just are able to execute whatever you want to execute on the shop floor with the help of these hyper robotized plants. They're also talking about during the day shifts for some specialty chemicals. They're talking about where people are really involved. Smart clothing, which has a big impact on HSE, the health, safety, and environment. You're able to track down your people on the shop floor wherever they are. In case of any emergency, you can evacuate them. There are a whole lot of liabilities and compliances one has to adhere to in terms of HSE policies in Europe. And hence, a lot of money is spent in these kind of initiatives as well. The other interesting thing that these guys are talking about is the use of digital twins to the next level. So basically, every asset that you have on the shop floor has a virtual twin of that equipment in your cyber world. And as it is running, you're able to visualize the wear and tear. You're able to visualize the amount of production it is doing. So it is going towards basically having, think about it just like you would have a twin of yourself. If you take a picture and if you put it in some kind of a digital format, it's a similar thing. The only thing is that it is live. So with the help of sensors and with the help of a whole lot of things like LiDAR, which is laser technologies, you're able to simulate how this particular equipment is running and when will it break down, when it will break down, what impact it will have on the upstream and downstream operations, and how do I need to plan for such changes. How do I maximize the utilization of my assets? Again here, with a keen focus on the fact that maintenance need not be time-based. Maintenance need not be condition-based. Maintenance needs to be based on the reality of how my equipment is currently. It's like saying if you have a car and you need to service your car every 6 months, even though it doesn't need servicing, but you still go ahead and do it because it is part of the guide given to you that you have to get your car serviced every 6 months. Digital twins help you actually bring down this cost because they let you know when is actually the wear and tear to an extent that you need to replace the spare now. Yep. And how do I actually ensure that I'm not changing things which have still some juice left in them? And this is what the technology adoption in chemical manufacturing in Europe is looking like. And the most important thing these guys talk about is that all equipment is watched. There are no surprises. It means you need to connect everything. And the reason for going this way is because of the fact, one, you need to be competitive enough. You need to be competing with the likes of the great explosion of chemical industry that we're seeing in India. China, of course. So how does Europe and US keep up? They invest in these things. I'm not saying that you need to invest in these as well, but what starts as a revolution actually flows everywhere. You cannot be actually sitting and taking a back seat and imagining that, well, labor is cheap in India and things are, from a compliance perspective, probably not so stringent and so on and so forth. But the reality of the situation is that once the engine kicks in, it's very difficult to stop it. And sooner or later, you'll find that these things will be knocking at your doors as well to make a decision. What we are seeing with some of your competitors outside, it's actually coming true with them aligning 2.5 to 3 crores in the first year with just a couple of plants to experiment how do these technologies help them. So most of us, and that's the reality, this was the reality of the European operations where people are talking about dark factories. When you talk to some of the Indian chemical manufacturers, they'll tell you, but we have an MIS team and they pretty much report everything to us on an Excel sheet. And they are there to track each and every data point. Why do we need to have these technologies? Well, if you actually look at your cars, the odometers and the speedometers that you have, you don't need an MIS guy there. You just look at the speedometer and tells you what the speed is. then why do your reactors, your evaporators, your condensers, and the equipment that you have on your shop floor, you need an MIS guy for that? It is also capable of giving you the same data that you want to see, but you would rather look at it at an Excel sheet. So coming back to where we started from, change is imminent, and change is actually taking place now. We can help you change. That's the business that we are in. We are a technology company specializing in the power of digital. If you find this interesting, then please visit us at our booth, and we'll be able to help you with a tailor-made specific pitch, which can help you with your digital transformation as it stands. So thank you very much. Any questions, I'll be happy to take.
Hi, this is Vishal.
Hi, Vishal.
Indeed informative, but I have certain questions. You said validation of SOPs and RCAs. See, after a point of time, after 10 years, if anyone has to see an RCA, what happens? If it is not up to the point, we need to, there should be some validation, right, for RCAs and other things. And what is the scope of data hubs here? Are you planning, means this technologies allow for data hubs for seeing data up to 10 years or more than that? Because a problem can exist even after 20 years, and people, if they are to visit it, at the validation of that, what is your say on that?
Yeah, very, very good observation. Yes, of course, now with the advent of big data technologies, the amount of data storage is not a challenge anymore. And in fact, if you look at the cost of storage also over the past years, it has come down drastically. Yeah, when you used to buy a hard disk 10 years back to what it costs you today, you see the difference there, right? Now, the cost of storage and the revolution as far as the, or rather developments in the big data side have really helped in answering this question. And if I tell you right now, just to give you an example, one of the plants that we work with, it's a huge plant. One of the plants that we work with pushes 1 terabyte of data every day to a cloud environment. So with that size of data, imagine the possibilities if you apply the right algorithms and the right analytical techniques. You're not limited by the processing of the human mind anymore. And that's exactly this revolution, what this revolution talks about. So very pertinent question. And yes, there are no limitations on storages anymore. And the technology allows itself to build more and more models so that you're always keeping your models updated. Yeah. So it's not that you build it once and then you put it in a store. Every new finding, you update the model so that going further, there are far more data points and analysis that you can bake in to your RCA than what you're used to doing.
Hi, sir. I'm Karthik Patel from GACL.
Hi, Karthik.
Very informative presentation, sir.
Thank you.
So I wanted to know, predictive analytics, it depends upon the data, right? What sort of data we are having. So based on the method of data collection and the correctness of this data, our predictions would be made. So what is your opinion regarding it? Like, if we haven't got sufficient data or we are having some incorrect data, then it would definitely impact the correctness of our prediction. So what is your say on that?
See, first of all, having some data is better than having no data. So you start somewhere. The second point is that as far as data cleansing is concerned, what you're referring to, making sense out of incorrect and making sense out of raw data, is again a program that you have to embark on. It's a one-time investment that you do to ensure that you put the backbone of data collection and data acquisition in place, so you can monetize it over and over. To give you a point here, you look at two sides. One is the OT integration side, which is time series data. It's historical data which is being fed to you every millisecond. Then there is ERP data, things like process orders, things like batch orders, materials masters data, recipe masters. How do you contextualize these two? How do you actually make sure, if you want to do some kind of a material variance analytics, you need to have information about your material master data. But how that data was actually consumed on machine is coming from the OT side. right? So how do you actually mash this up together is where the magic lies. And thankfully, now we're standing in a very interesting juncture in our lives where everything is, again, changing. These technologies are available to us. So what you saw happening with the invention, or rather the coming of internet, is a similar kind of a revolution happening on the OT-IT integration side in real world right now. The impact of this will only be visible in next 5 to 7 years, where this industry is itself supposed to be more than $6 trillion industry. Not only just chemicals, but a whole lot of other industrial segments. So the digitization itself is a $6 trillion industry coming in next 5 years, staring at your face.
Thank you, sir. So what are the changes on the hardware part that are involved? Are there any hardware changes involved? Or
there are ways around not going for a hardware refresh. A lot of things are possible without a hardware refresh. You can visit us on our booth and we'll be happy to talk about it.
Thank you, sir.
Yeah, you're welcome.
One of the interesting observations that you made was about 30% of the companies are getting their focus of their digital transformation strategy wrong.
Yeah.
So Indian companies who are right on the edge of the learning curve now, would they end up committing the same mistake?
You know, I'm an Indian myself. I take great pride in the fact that Indians are very smart when it comes to doing something which others have failed at. There's a saying by G.B. Shaw. He used to say that let the scars of others teach you caution. And I think Indians are very good at learning caution. The programs that we are seeing are actually very well structured programs. They're trying to imbibe the learnings from their competition and their counterparts across the world. The good part about starting late is that you can start from the point where your competition has already reached, because you don't have to travel that journey. You can start your journey at a at a milestone which they have already covered. Their learnings you can imbibe, and I think that's what's happening in the Indian sector right now. As far as our India operations in terms of sales only started last year in February. In the last 1 year, we've had interactions, if not less than 40. How many? Around 40 chemical manufacturers are in advanced stage of conversations with us, with 3 of the largest manufacturers out of India already signed up. And they have pure, I would say, organograms wherein they have a digital officer, they have powers allocated at the right departments to make this program work. So yeah, I'm very hopeful of this journey in India.
Thank you.